trigonometric ratios of some specific angles. Okay, this is related to concept. This is 8.3. What are some specific angles? Let us say 30 degrees, 45 degrees, 60 degrees and 90 degrees. See, if angle A is equal to 45 degrees, okay, if angle A is equal to 30 degrees, if angle A is equal to 60 degrees, if angle A is 90 degrees, what will be the trigonometric ratios values? First we will start with, okay, including 0 degrees also we will consider, okay. But in this slide, what we will do, we will calculate trigonometric ratios for angle A is equal to 45 degrees. Now consider, in triangle ABC, right angle at B, if one angle is 45, then other angle is also 45 degrees, correct? Suppose if this is right angle, B, 90 degrees, if angle A is 45, it should be 45, right? Why? Sum of all the angles in a triangle is equal to 180 degrees, correct? That's why if angle A is equal to 45, angle B is equal to 90 degrees, then angle C will be 45 degrees. That means what? Angle A and angle C will be equal. Angle A is equal to angle C is equal to 45 degrees. Can you see, if angle A is equal to 45 degrees, angle C is equal to 45 degrees, then what happens is, side AB and side BC will be equal. Why? Sides opposite to equal angles are equal. Okay, these sides AB and BC opposite to equal angles A and angle C are equal. Okay, now suppose, assume that BC is equal to AB is equal to A. We can consider, right? The length is equal to A. Okay, then use Pythagoras theorem. You will evaluate AC, hypotenuse. AC square is equal to AB square plus BC square. That is, AC square is equal to A square plus A square is equal to 2A square. Then AC is equal to A root 2. Yes, we have all the sides, right? We know all the sides. Okay, we know this side is A, this side is A, and this side is A root 2. We can very well evaluate, or you can write the trigonometric ratios for 45 degrees of angle A, correct? Instead of calling angle A, we will say 45 degrees. Sine 45 degrees is equal to side opposite to angle A, that is side opposite to this 45 degrees, correct? And by hypotenuse, right? Then BC by AC is equal to A by A root 2 is equal to 1 by root 2, correct? Cos 45 degrees. What is cos 45? Adjacent side, side adjacent to angle 45 degrees by hypotenuse. AB by AC is equal to A by A root 2 is equal to 1 by root 2, correct? Tan 45. Tan 45 is what? Side opposite to angle 45 degrees and side adjacent to angle 45, that is BC by AB. What is BC? A. And what is AB? A. A by A is equal to 1, correct? Similarly, we can write cosecant 45. What is cosecant 45? Reciprocal of sine 45. 1 by root 2 is nothing but root 2. What is secant 45? 1 by cos 45 degrees. Okay, that is root 2. Okay, then tan 45. Cot 45 is equal to 1 by tan 45 is nothing but 1. Okay, so we have calculated trigonometric ratios for 45 degrees, right? Okay, then we'll go to next slide. Trigonometric ratios of 30 degrees and 60 degrees. Consider equilateral triangle ABC. In equilateral triangle, angle A is equal to angle B is equal to angle C is equal to 60 degrees. This is 60, this is 60, this is 60. And you draw a perpendicular from A to side BC. Okay. Now, triangle ABD is congruent to ACD. Congruent. This symbol is called congruent. Okay. Reason why ABD is congruent to ACD is the perpendicular drawn from this vertex bisects the side BC and it also bisects the angle A. Okay. Then AB is equal to AC, BD is equal to DC, AB is equal to AC. Correct? And the corresponding angles are equal. What are the corresponding angles? Consider this triangle ABD and ADC. Angle B is equal to and the corresponding angles are equal. Okay, just remember that. Okay, angle B is equal to angle C. Angle Angle BAD is equal to angle CAD. Correct? This angle and this angle are equal. Can you see what is this CPCT? Right? CPCT means corresponding parts of congruent triangles. Which are the congruent triangles? ABD and ACD. Congruent parts means, okay, angle B and angle C, okay, and this angle and this angle, this angle and this angle, and this side is equal to this side, okay, this BD is equal to DC, okay, like that, okay, then corresponding angles are equal and corresponding sides are equal, okay. Now, okay. Now can you see triangle ABD? What? Angle BAD is equal to 30 degrees. Angle BAD, that means this angle is 30 degrees and angle ABD is 60 degrees. Now, for finding the trigonometric ratios, what we need? We need to know the lengths of the sides of this triangle. What is AB, what is BD, what is AD, correct? Now let us assume AB is equal to 2A, okay? Then BD is equal to what? BC by 2, this is nothing but A, correct? Now AD, using Pythagoras theorem, AD square is equal to AB square minus BD square. Then it is equal to 2A square minus A square is equal to 3A square is nothing but AD is equal to A root 3. This AD is equal to A root 3. Now we have all the sides. This is A, this is 2A, this is A root 3 or root 3A. Now simple, right? You write now first 30 degrees. Sine 30 is opposite side by hypotenuse. Opposite side is what? BD divided by AB is nothing but BD is A, sorry, you correct this, A by what is AB? 2A is nothing but 1 by 2, right? Please correct this. A by 2A is equal to 1 by 2. And what is cos 30? Cos 30 is, consider this angle cos 30, that is adjacent side AD, that is A root 3 divided by hypotenuse AB is 2A. A root 3 divided by 2A. It is nothing but root 3 by 2. Okay. Now, what is tan 30? Tan 30 is equal to opposite side. Tan 30 is equal to opposite side by adjacent side, that is BD by AD. BD is A and AD is A root 3, it is 1 by root 3. Similarly, okay, similarly what we have to write? Cosecant 30. Cosecant 30 is 1 by 30, is nothing but 2. What is secant 30? Secant 30 is reciprocal of cos 30, that is 2 by root 3. Okay. And what is, I have not written here, but what is cot 30? Reciprocal of tan 30 is root 3, correct? Now, similarly, for trigonometric ratio of 60. Consider this angle. Then if you consider this angle, what is opposite side? AD will become opposite side, BD is adjacent side, AB is hypotenuse. Then sin 60 is equal to AD by AB, opposite side by hypotenuse AB. That is AD by AB is equal to, that is A root 3 by 2A is equal to root 3 by 2. Okay, cos 60 is equal to BD by AB, that is adjacent side by hypotenuse. A by 2A is equal to 1 by 2. Similarly, tan 60 is AD by BD is equal AD by BD is equal to A root 3 by A, that is 3. Cosecant 60 you can write like this, or you can say reciprocal of sin 60, but we will write cosecant 60 is AB by AD, that is 2A by A root 3, it is equal to 2 by root 3 is nothing but reciprocal of sin 60. Cosecant 60 reciprocal of cos 60 is equal to 2. That means what? Cosecant 60 is AB by BD is equal to 2A by A is equal to 2. Cot 60 reciprocal of tan 60 is nothing but 1 by root 3. How it is? Cos 60 is BD by AD. BD is A and AD is A root 3, that is 1 by root 3. Okay. So we have completed what? 30 degrees, 60 degrees, and in the previous slide we have completed 45 degrees. Now we will go to next one. Trigonometric ratios for 0 degrees. Okay. Now consider this triangle ABC. Okay. This is angle A. Okay. Let us see what happens to the trigonometric ratio of angle A if it is made smaller in the right angle triangle ABC till it becomes 0. That means what? You move this AC, if angle is becoming, it is becoming 0, 0, 0, what happens? AC will become like this, right? From here, consider this AC and keep on moving this, like this, like this, like this. Then what happens? The angle becomes 0 and AC will be equal to AB, correct? Correct, no? As angle A gets smaller and smaller, the length of the side BC decreases. This side BC decreases, right? Decreases, BC decreasing and becomes 0. See, the point C get closer to point B. C becomes B, and okay, and finally when angle A becomes very close to 0, AC becomes almost same as AB. AC is equal to AB and BC is equal to 0. Okay, now when angle A is very close to 0 degrees, BC gets very close to 0, correct? And so the values of sin A is very close to 0. Why? What is sin A? Reason. Okay, reason is sin A is equal to what? Sin of angle A is equal to BC by AC. BC became 0, no? At 0 degrees BC became 0. That means 0 by AC, 0 by value. Correct? That means what? Sin 0 is 0. Correct? BC becomes 0 units, right? Okay. And also when angle A is very close to 0 degrees, AC is nearly same as AB. And so the value of cos A is very close to 1. Why? What is cos A? AB by AC, AB by AC, AB by, when angle A becomes 0, AC is equal to AB, right? Then I can write, instead of AC, I will write AB, AB by AB is equal to 1, as AC becomes equal to AB when angle is 0 degrees, correct? Now, we arrived that sin 0 is equal to 0, cos 0 is equal to 1. Now, this helps us to see how we can define the values of sin A and cos A when A is 0 degrees. We define that sin 0 is equal to 0, sin 0 degrees is 0, cos 0 degrees is equal to 1. Using these values, we can find other trigonometric ratios, right? Tan 0 degrees is equal to sin 0 by cos 0. 0 by 1 is equal to 0. Then, what is cot 0? Reciprocal of tan 0, 1 by 0, which is not defined, right? Value by 0, not defined. What is secant 0? 1 by cos 0. 1 by 1 is equal to 1. What is cosecant 0? Cosecant 0 is 1 by sine 0. 1 by 0 which is not defined, correct? So we have completed for 45 degrees, 30 degrees, 60 degrees and for 0 degrees. Now we will go to next slide to evaluate for 90 degrees, okay? Trigonometric ratios for 90 degrees. Consider the same triangle ABC, right angle at B and angle A. Okay. Okay. Now let us see what happens the trigonometry of angle A when it is made larger, larger and larger till it becomes 90 degrees. Okay. As angle A gets larger and larger, okay, what happens? Angle C gets smaller and smaller, correct? This closes, right? Angle C reduces and angle A becomes 90 degrees, correct? Therefore, the length of AB goes on decreasing. This AB goes on decreasing and becomes 0. And AC becomes equal to BC, correct? The point A gets closer to point B when angle A becomes 90 degrees. Finally, when angle A is close to 90 degrees, angle C becomes 0 and then the side AC is almost equal to side BC, correct? Now, we will write the ratios. When angle C is very close to 0, angle A is very close to 90 degrees. Then AC is nearly same as side BC. And so sin A is very close to 1. How it is 1? Sin A is equal to what? BC by AC. BC by AC, you can write BC by AC because at 90 degrees BC is equal to AC, right? So I will replace AC with BC is equal to 1 as AC becomes BC, AC is equal to BC at 90 degrees, correct? Also when angle A is very close to 90 degrees, angle C is very close to 0 degrees, then side AB is nearly 0, then cos A is very close to 0. Why? The reason I am telling you here, okay? Reason is cos A is equal to AB by AC, and 0 by, AB becomes 0, right? 0 by AC becomes BC. I can write, right? AC as BC, 0 by value is equal to 0. AB is equal to 0 units, correct? When angle A becomes 90, AB becomes 0 units, right? Now we know that sin 90 is 1, cos 90 is 0. With these, you can evaluate other values. Tan 90 degrees is equal to sin 90 by cos 90, 1 by 0, which is not defined. And what is cosecant 90? 1 by sin 90 is equal to 1 by 1 is equal to 1. Secant 90 is what? 1 by cos 90. Okay? Okay? Which is not defined. And cot 0 is, you write like this. Okay? Don't write 1 by tan 90. You write like this. Cot 0 degrees is equal to cos 90 by sin 90. Okay? Cos 90 by sin 90 is what? 0 by 1 is equal to 0. Okay? Alright. Now, just now we calculated the trigonometric ratios for specific angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. We evaluated all the trigonometric ratios, right? In a tabular form, if you written no, sin 0 is equal to 0, sin 30 is equal to this, 1 by 2, sin 45 degrees is 1 by root 2, sin 60 degrees is root 3 by 2, sin 90 is 1. Okay? Like this you can formulate this table. Okay? From the table above, you can observe that angle A increases from 0 to 90 degrees, sin A increases from 0 to 1 and cos A decreases from 1 to 0. Can you see? 0, if you write sin A and reverse the sin A, it becomes cos A for other degrees, correct? Yes. Okay. With this, we have completed trigonometry ratios for some specific angles. Okay.